All right, so we are going to list out the first 5 lines of Pascal's triangle. I mean, you can go further if you want to, but I'm never going to give you one that's above to the 5th. All right, so starts with 1, and then the next line is 1, 1. I know it's like super interesting there, but now we're going to have some other numbers. What's the next line going to be? But 1, 2, 1. You're just adding what's above there. 1 plus 1 is 2. All right, and then what's the next line going to be? Good. 1, 3, 3, 1, and then you are. All right, and then 1, 4, and then what? Good. 6, 4, 1, and then one more. 1, 5, 10, 10, 5. Perfect. All right, again, you can go further, but that's as far as I need you to go. We're going to do the first one together, and then I'm going to pause this, and I'm going to give you guys some time to work on the other 4, with the people around you. So this is to the 4th. So you're going to use the line with the 4s in it. And if you want to go ahead and write out your coefficients, 1, 4, 6, 4, 1. And then we're going to start with x to the 4th, and it's going to be a countdown. So x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the nothing. And then when we do the 1, it's going to go the opposite way. So it'll be 1 to the nothing, 1 to the 1st, 1 to the 2nd, 1 to the 3rd, 1 to the 4th, and then put pluses in between them all. One is an easy number to deal with because 1 to any power is just going to be 1. So that's going to be kind of nice. That is essentially the answer. We just need to simplify it down. You can scribble out anything that is to the 0 power. Anything to the 0 power is 1. That's not going to change. And this will be x to the 4th plus 4x to the 3rd plus 6x squared plus 4x plus 1. Again, that one was kind of nice because 1 to any power is just going to be 1. All right, so for this one, it is to the 5th. So we're going to use this line, 1, 5, 10, 10, 5, 1. And so we'll start with x to the 5th, and then it'll go in our countdown to the 4th, to the 3rd, to the 2nd, to the 1st, x to the nothing. And then this one is -2. So what's going to happen with the terms for this one since we have subtraction? Good, they're going to alternate. It'll be positive, negative, positive, negative. So this will be -2 to the nothing. This one's going to go the opposite direction. -2 to the 1st, to the 2nd, to the 3rd, so on and so forth. And then you can put pluses in between them all, but it is going to alternate when we simplify it down. So you can scribble out anything that's to the 0 power. That's just anything to the 0 power is 1, so it's not going to change anything. So this first term is just x to the 5th. -2 to the 1st would just be -2 times 5 would be -10. So minus 10x to the 4th. And then for this one, -2 squared would be what? Good. 4, good, +4, right? Times 10 be 40. So 40x to the 3rd, -2 cubed. What is that going to give us? Not 8, but -8. Good, that'll be -8 times 10 will be -80, x to the 2nd. -2 to the 4th, that'll be 16 times 5 is 80. So 80x minus -2 to the 5th will be 32. You can count on your fingers. It's 2 times 2 times 2 times 2 times 2. It's just negative because of the negative. So check that one. Make sure your answer came out right. I'm going to pause it again and give you another minute to work. Try them. Talk to the people around you. You can work together, and then I will give you the answers. Yeah, I mean, just looking around, it looked like everyone had at least tried this one, so I'm going to write the answer up. All right, I'm going to read out the answer to the third one. You can check it. It should be 16x to the fourth plus 32x to the third plus 24x squared plus 8x plus 1. Yeah, you have to do the power first. So like, for example, this one, 2 to the fourth is 16. That's where that came from. Right here, 2 cubed is what? That'd be 8, and then times 4 is where we got 32. Yeah, good. And then this one, 2 squared would be 4 times 6 is 24. You kind of lucked out there because the other number was 1, so you don't have to even deal with that because you don't have to multiply by 1. This one's not really going to have any math at all because they're both variables. Your coefficients would be 1, 3, 3, 1. And we're going to start with x to the third. So x to the third, x to the second, x to the first, x to the nothing. And then this would be negative y going the opposite direction. And so the terms are going to alternate because we had subtraction there. Again, anything to the 0 power, you can just scribble out. Like that's just going to be 1. So this will be x to the third minus, because a negative to the first is going to be negative, minus 3x squared y. And then this will be plus 3xy squared. If you take negative 1 and square it, it's going to be positive 1. And then this will be minus y cubed. So that one was tricky because there was a negative. The other thing I have people do with the negative sometimes, like I do it this way. The other thing you can do is treat that like a positive y and then just make your terms alternate at the end. Does that make sense? Like you could just almost like ignore the negative and then at the end, just make your terms alternate. That's the other way you could get through that. All right, I'm going to pause it one more time. Go ahead and try the last one and then I'll go over it. So what are your coefficients going to be for this one? 1, 3, 3, 1. And you know, like on a quiz or test, it's a point for each thing you do. So like if you pick the correct coefficients, I'm going to give you something. All right, we're going to start with x to the third. So x to the third, x to the second, x to the first, x to the nothing. And then we're going to use the 2y. It's going to go in the opposite direction. So 2y to the nothing, to the first, to the second, to the third. And again, that's essentially the answer. Like if you are getting there, you're going to get like most of the credit. You know what I mean? Like that's the answer. Simplifying it is like the last little step, right? Anything to the 0 power, you can scribble out. This first term will just be x to the third. For this one, 2 to the first would be 2 times 3 is 6. So 6x squared y. All right, for this one, 2 squared. 4 times 3 is 12, x, y squared. I know we're all tired today. 4 times 3 is 12 though, everybody. And then this last one, 2 cubed is 8. And so that's 8y cubed. So again, if like that last step is the thing you're struggling on, don't stress yourself out over that. If you have this first part correct, like you're gonna get most of the points on it because that like essentially is the answer. This is just like simplifying it down. All right, so for these rational graphs, the first thing you would want to do is factor this. I started with an easy one. You know, I always start with like an easy example and then they're going to get harder, okay? I hear that all the time. It's cool. It starts out really easy and then gets harder. Yeah, I designed the lessons that way. Do you know what I mean? I'm not going to give you the hardest example first. So anyway, this does not factor, but that is the first thing that you would want to do. Then you want to do the domain first. You're going to exclude where the denominator is 0. And again, I'm going to take a picture of this and I'll post it to Schoology. It'll be there. You're going to exclude where the denominator is 0. You're not allowed to divide by 0. And this is the thing, I call it the domain party. And I'm like, who's not invited to the domain party? Okay, that's the first thing that you want to do. So looking at this one, hey guys, who is not invited to the domain party? -2 is a troublemaker. Kick them out. How do we write that? That we want to, everybody except -2. Negative infinity to -2 with a parenthesis is crucial. It has to be a parenthesis because you're trying to leave it out. Union -2 to infinity. What you're saying is you want everything to the left of -2, everything to the right of -2, but not -2. All right, once -2 gets kicked out, there are two sort of career opportunities for -2 now that it's been excommunicated. It can either be a hole or a vertical asymptote. So I would do these three things kind of together. Whatever gets kicked out of the domain, it can either be a hole or a vertical asymptote. It can't be both. Question? Okay. If something cancels out, it is a hole. If something does not cancel out, then it is a vertical asymptote. So did anything cancel out here for this problem? You guys are really tired. Did anything cancel out? No, it did not. Okay, so that means that there is not going to be a hole. And instead, our -2 that got kicked out of the domain, that's going to be the vertical asymptote. Vertical is x equals, so x equals -2. So do those three things together. Whatever gets kicked out of the domain, it can be one of these two options. And then we can go ahead and put that on our graph. X equals -2. So it's going to be this vertical line at -2. So do those three things together. That's my suggestion. All right, then I would look for the horizontal or slant asymptote. Slant asymptote is new. You didn't do that in Algebra 2. You did horizontal asymptotes, but you didn't do the slant ones. They're not hard to find, and I'll teach you how to do it. All right, that's what I would do next. So your horizontal or slant asymptote. There's a little bit more to this. You have to compare the degree of the numerator and the denominator. It's kind of like who's in charge here. All right, so if the numerator degree, and I'm going to abbreviate that, numerator degree, if that is smaller than the denominator degree, the numerator is smaller than the denominator, it is automatically y equals 0. Here's how my brain remembers that. The numerator is smaller than the denominator. You get a situation that is like 1/2, 1/3, 1/4, 1/5, 1/6, 1/7. Do you get where I'm going with this? 1/8, 1/9, 1/10, until you get out to 1/1 trillionth. And if I offered you 1/1 trillionth of a slice of cake, you would be like, gee, thanks, Miss Cole, because it is essentially 0. Your horizontal asymptotes are the ends. You're going out to positive and negative infinity. So you're thinking about those like really huge numbers. It's going to level off at 0. All right, the second option, if your numerator degree equals the denominator degree, so like it's a tie, I think that's usually everybody's favorite version of things because they're like, oh, they're the same. Then it's y equals your leading coefficients. So you just take whatever the numbers are out front, and that's your horizontal asymptote. All right. So if numerator degree is less than, it's automatically 0. If it's a tie, then you use the leading coefficients. If your numerator degree is greater than the denominator degree, that's where you have a slant asymptote. And I'll show you how to find them. It's not hard, okay? Instead of leveling off like this, it levels off like this. You know what I'm saying? Like, you'll have a line that has a slope to it. So let's look at this one. Numerator degree. There's not an x at all. It's really x to the nothing, if you want to think of it that way. That degree is 0. What's this degree? It's really x to the what? 1. So which one of these situations do we have? Numerator degree is 0, denominator is 1. Which one of these three things is it that we have? Y equals 0. The numerator is smaller than the denominator, so this is automatically, it's a horizontal asymptote, automatically going to be y equals 0. And you need to circle which one it is. Is it horizontal or is it asymptote? And so that's going to level off at 0. I know that's kind of hard to see because it's on the axis. You can use a highlighter if you want to. And you want to just dot it at the edges. Horizontal asymptotes are really just for end behavior, so it's just at the edges. All right, so let's go back and get some points to put on here. We have the asymptotes, but we don't have any points. Let's get our x and y intercepts. So your x-intercepts It's going to be something, comma, 0. And so it is where the numerator equals 0. So you set the numerator equal to, essentially you're setting the whole thing equal to 0, but if the numerator is 0, then it's going to equal 0. Your y-intercept is going to be 0, comma, something. And so for that, you're just going to plug in 0. You plug in 0 and you see what you get. So let's apply that to the problem that we're doing here. If we try to set this numerator, let me erase all the markings I put on here. If we try to set this numerator equal to 0, okay, kiddos, that would be 3 equals 0. Does that make any sense? No, so there just aren't any, none. There's not even a variable in the numerator, so we can't set that equal to 0. Y-intercept, we can do that though. We're just gonna plug in 0. So if you plug in 0 for this x, what do you get? Like, what's the result? Yes, 3/2, which would be 1.5. And so you can put that point on your graph, like right about there. Good enough, as long as it's in between 1 and 2. And once you have the intercepts and the asymptotes, you can go ahead and draw in the graph. I'm not picky about these ones. I don't need any more specific points. As long as you don't run into these dotted lines, we're good. Just draw that in. It's going to be like your hourglass kind of thing. If you want more specific points, you're like, hey, Miss Cole, that's not good enough for me. I want more points. Make yourself an XY table. You can plug in whatever you want and see what you get. All right, range. Let's go back and get all the stuff that we're missing. You're going to exclude the horizontal asymptote, if there is one, and the y value, because range is y values, of the whole. You have to leave that out because a whole is missing. You'd have to exclude that. The horizontal asymptote is where the graph levels off. It's never going to touch there. If you don't like how this is written out like this, you can also just look at it, scanning downwards to upwards, like what gets left out, like who's not invited to the range party for this one. Yeah, 0. Do you see how the graph's never going to touch 0? And there is no hole, so we don't have to worry about that. You're just going to leave out 0. And you write it the exact same way that we did the domain. It's just 0 is the number that's getting left out. It's no different than what we've done before. Domain, you're scanning left to right. Range, you're scanning downwards to upwards and just seeing what got left out. All right, increasing and decreasing. This is not new information. You're going to read your graph left to right. So read it left to right, see if it's going up or going up. I'm not teaching you what increasing and decreasing means. Do you know what I mean? Like, you walked into this room knowing that increasing means going up and decreasing means going down. What I'm teaching you is the notation of how to write it and just reminding you that you have to read left to right. So hey guys, as we read left to right, what is this graph doing? Going down. Even on this side, as we read left to right, what's it doing? Going down. It's decreasing all the time. So increasing is none. It's just not doing that. And if it decreases all the time, it decreases for the entire domain. So you can just copy the domain answer over for your decreasing. It's going to decrease all the time. So you just copy over the domain. Here, and I'll put that on these notes here. All right, and then the last thing is the end behavior. It's going to be the same as the horizontal asymptote if there is one. If you have a slant asymptote, it's going to be going up or going down. It'll be positive or negative infinity. But if you have a horizontal asymptote, the end behavior is going to equal that. It's going to have to be the same. Where are both of these ends leveling off, guys? 0. Will it ever actually touch 0? No, it's behavior. And again, I got somebody one year that was just, he almost yelled at me. It was kind of funny. It's cool, there are too many arrows on this graph. And I was like, I get you. And I was like, we gotta come up with a way around this. I was like, take your hand and cover up the middle of the graph. And then these are the 2 arrows that you want to look at. Those are your ends. So they're both leveling off at 0. So it is limit as x goes to negative infinity of the function, limit as x goes to positive infinity of the function. That's how you write that. The left end and the right end, and they're both going to 0. Again, it won't ever actually touch 0. It's just the behavior. We're just going to apply that to a few more problems. Like anything else, it's a drill and practice thing. You just got to practice a few of them. So let's try another one. This one you actually can factor. If you guys could pretty please go ahead and factor that, compare with the people around you, and we'll make sure we all get the same thing. All right, how did you guys split up the numerator? Good, perfect. And it doesn't matter which order you put those in. Difference of squares. All right, and then the denominator, what do you guys think about that one? Good, yeah, the 3 is going to be 1 times 3. To get -2 in the middle, you would have to have +1 minus 3. So first, we're going to do the domain. There are 2 troublemakers this time. There are 2 values that have to get excluded from the domain party. Who are they? -1 and 3. Does it matter what order you put them in? Yes, you have to go smallest to biggest. So we're going to leave out -1 and we're going to leave out +3. So this is saying we want everything to the left of -1, everything in between -1 and 3, and then everything to the right of 3. You just keep leaving out those numbers, like you're just skipping over them. I wouldn't give you more than 2 to leave out, but do you guys understand that, like, in theory, if you had to leave out more numbers, you would just keep unioning it on? It's not harder, it's just a longer answer. Now, since -1 and 3 have been kicked out, they can either become a whole or a vertical asymptote. If it cancels, it's the whole. If it doesn't cancel, it's the vertical asymptote. All right, let's do the whole first. Which one cancels, the 3 or the -1? 3. The whole is going to be 3 comma something. This is gone. This is probably the most missed thing I see, is where to get that something. It is like anything else we do. If you have an X value, how do you get the Y value? Plug it in. That is literally it. You have to plug it into what's left here. So we're going to plug in 3 already. 3 plus 3. 6. Here, I'll write a little note. The numerator is 6. Down here, 3 plus 1 is 4. If you wrote 6/4, I wouldn't take off for that, but let's reduce that. That would reduce to what? 3/2, or 1 1/2. So you can put a whole on your graph there, 3 and then 1 1/2. Close enough. Like 1 1/2 would be between 1 and 2. When in doubt, just make the open circle bigger. But like, if it's close enough, I'm not here to grade your art skills. You know what I'm saying? Like, if you get it in the reasonable vicinity, I'm happy. So then what's the vertical asymptotes? 3 became the whole. What's our vertical asymptote going to be? Yeah, -1. Now you have to write x equals -1. So we kicked out 3, we kicked out -1. These are the 2 things they can become. 3 became the whole because it canceled. -1 became the vertical asymptote because it didn't. And you can dot in that -1 as well. All right, next do the other asymptote. You have to compare the degrees. Look back at the original problem. What do you notice about these degrees? They're the same. When it's a tie, what did we say we use? Leading coefficient. This is a little tricky because they're not written in. What are the coefficients for both of these? 1. Oh, I guess that wasn't tricky. You guys got that. 1/1 is 1. So horizontal asymptote, y equals 1. And you want to just dot that at the edges. Again, the horizontal asymptotes are just end behavior. That's it. Going to level off at 1. All right, now we're going to go back and get the intercepts. X-intercept is going to be something 0. Look at what you have left here in the numerator. Once we factored it, we canceled out. Here's what's left. What's going to make this 0? -3. Good. -3, 0. And you can put that on your graph. So I was looking at the factored version here. We canceled this out. What makes this 0? It'd be -3. -3 plus 3 is 0. Y-intercept is going to be 0, something. You're just going to plug in 0. You can plug it into the factored version or the original version. It really doesn't matter. I think the factored version is a little shorter, obviously. If you plug in 0, you get 3/1, which would just be 3. So 0, 3. And then I'm good. You don't need to find any extra points. That's enough. Just go ahead and connect it all and don't run into the asymptotes. And the other thing I always have to tell everybody is make sure you connect to the hole, because I get people that'll do this, like the hole will be right there. Don't do this. This is wrong. Okay. But the hole will be right there and they'll draw in their graph like this. Do you understand why that's not like why that's a problem? Like the hole has to be like, it has to be a hole in something. And what I usually do is I tease people and I'll draw this on their paper and I'll be like, is that the sun? Like, so if you do it, I'll tease you a little bit. Okay. But just make sure you incorporate the hole into the graph because it's part of the graph. All right. Then we're going to go back and get everything else. The range. You're scanning downwards to upwards. There's 2 values that are getting left out now. Who is getting excluded? 1, because that's the horizontal asymptote. And then also what else? 3/2. There's a hole there, so you have to leave it out. We're going to leave out 1 and we're going to leave out 3/2. And you write it the same way as the domain. It's not any harder, it's just more to write, that's all. So we're going to skip over 1 and we're going to skip over 3/2. They got left out. All right, increasing and decreasing. You have to read left to right. So what's our graph doing all the time here? Decreasing. That means on the decreasing line, what are you going to copy over? Domain. And hey guys, if your domain was wrong, but you copy it over here for decreasing, then I would not take off for your answer there. So like if your domain is incorrect, but you copy it over correctly, I'm going to give you full credit for those. And then increasing would be none, because it doesn't do that. And then for the end behavior, limit as x goes to -infinity of the function, limit as x goes to +infinity of the function. Just saying what happens to the left and the right. And now it's never going to actually reach this value, but where is it leveling off? Like what's it getting closer and closer to? 1, and it should match this answer. If you have a horizontal asymptote, those should all be the same. So again, if your horizontal asymptote's wrong, but you make this match, I'm going to give you full credit for your end base. Let's try one more and then I'll give you a break. This one does not factor. You can't split x² + 1. Let's talk about that really quick. Let's say it was x² - 1. That you could split. What would that split into? Yeah, good. That's a difference of squares. Why won't it work for this though? Yeah, it's not, I mean, you have to have a positive and a negative to make a negative. If it's plus, it's not going to work. All right, so this does not factor, which is actually kind of nice because it's less work. You don't have to do anything. All right, who is not invited to the domain party? -2 is a troublemaker. Kick him out. Get rid of -2. Don't feel bad for -2. -2 is causing problems. It made a 0 denominator. You got to get rid of it. What are the 2 things -2 could now become? Like, what are his career choices now that he's been kicked out? A hole or a vertical asymptote? He can't be both. Which one is it going to be? Good. Why would it be the vertical asymptote and not the hole? Because that is correct. Yeah, nothing cancels out. We have no hole. So none for that. Don't you love the none answer? That's great. All right, so x equals -2. You can dot that in. All right, and then you would want to do the horizontal or slant asymptote. Compare the powers, compare the degrees. This one is 2, this one is 1. That means this one is going to be a slant asymptote. Numerator is bigger than the denominator, so slant asymptote. Go ahead and circle slant. This is the new stuff. You didn't learn this last year. Or did anyone do slant asymptotes? I don't think you do that in algebra 2, right? It's not hard. It's just one more step. What you're going to do is a synthetic division. Oh, that's why you don't do them in algebra 2, because you don't do synthetic division in algebra 2. -2 is going to go in the little box off to the side, and we're going to divide it out and see what's left. As a heads up, your countdown is missing something. What is it missing? The x's. Good. There are no x's there. So your coefficients would be 1, 0, 1. Go ahead and divide it out. You're going to bring down the first number and then multiply, add, multiply, add. I like when people are like, I thought we were done with this. That doesn't ever happen in math class because math always builds on itself. So nothing's ever like over. Did you get 1, -2, 5? Okay, we do not use the remainders. So you can just cross that out. The reason why is these asymptotes go to positive and negative infinity. Don't try to think about infinity too hard. Our brains can't handle it. Like, don't hurt yourself, you know what I'm saying? But like, think about like the biggest number you possibly can. This remainder is so tiny by comparison. It is like a teardrop in the Pacific Ocean. Do you get what I'm saying? Like, we just get rid of it because it becomes insignificant when you think of like infinity. But don't try to think about infinity too hard. But anyway, it's super tiny. That's why we don't use it. So here's your slant asymptote. Y equals 1x minus 2. It's 1x minus 2. So welcome back to Algebra 1 class. Remember y equals mx plus b? Where like for 3 months of your life, everything was y equals mx plus b. That's what this is. You're going to start at -2 and your slope is 1. Just instead of actually drawing in a line, just like dot it in. So you're going to start at -2 and then it's up 1 over 1, just like make it a dashed line. And the graph is going to level off, well, I shouldn't say level off, but like coast along that dotted line like this. And I just like doing this because it looks like I'm dancing. I'm going to do this. All right, so let's go back and get the intercepts. X-intercepts would be where the numerator equals 0. This numerator is never going to equal 0. Here, I'll show you. We can try. X squared plus 1 equals 0. What would you do to solve that? -1, and then what? So you get answers, but they are imaginary. You would have plus and minus I. We don't deal with imaginary numbers on a real graph. You would just say none. Don't put I on there. You can't graph an I, it's imaginary. Y-intercept, we will have that though. Plug in 0 for x, what do you get? If you plug in 0 for these x's? 1/2, perfect. So you can plot that 0, 1/2, good enough. It'll be like there-ish. And then all you have to do is coast along the asymptotes and go through this point. It's the only point we have on there. So it's going to do something like this. And I'll zoom way in on that so you can see it better. And it still looks kind of like an hourglass. Yeah, like each of them, they're technically not, but yes, I see what you're saying. And like also like my art skills aren't perfect. And if you were to put that in the calculator, it'd actually be more like this. I don't know. Good enough. All right, end behavior. Let me zoom back out a little bit. So it's limit as x goes to -infinity of the function, limit as x goes to +infinity of the function. And again, what I'm going to do is just take my hand and cover up the middle of the graph. So I'm covering up this. That means these are the 2 arrows you want to look at. If you just cover up the middle. That seriously helps so much. Just cover it up. Where does the left arrow go? -infinity. Good. And then where does the right arrow go? +infinity. All right. We're going to factor the numerator. The denominator obviously won't factor, but let's go ahead and split up the numerator. It'll be x and x, and then what? 2 and 1, good. I always do the numbers first and then the symbols last, because then you only have to worry about one thing at a time. So 2 and 1, and then what symbols would you need? Plus and minus. So who is not invited to the domain party? Who is getting kicked out here? 1. 1 is a troublemaker. Kick him out. Silly 1, making a 0 denominator. So what 2 things can 1 become? A whole or vertical asymptote? Those are his 2 choices. He can't be both, one or the other. It's going to be a whole. So that means vertical asymptote is none, because again, it can't be both. So if 1 is going to be the whole, it can't be the vertical asymptote. But hey, Miss Cole, wasn't there a problem where we had both a whole and a vertical asymptote? Yeah, why was that okay on that problem? There were 2 numbers that got kicked out. So one of them was the whole and one of them was the vertical asymptote. But if you only have one number, it's got to be one or the other. All right, how do I get the other something here? Plug in 1. Now you have to cancel this out first, and then plug in 1. 1 plus 2, 3. So the whole is 1, 3. All right, then we're going to do the horizontal or slant asymptote. Compare the powers. Numerator is 2, denominator is 1. So what is it going to be? It'll be a slant asymptote. The numerator power is bigger, it's going to be a slant asymptote. So 1 is going to go in the little box. Hey, Miss Cole, is that always going to be that troublemaker number? Yeah, whatever you left out of the domain, that's going to go there. What are our coefficients for our countdown? 1, 1, -2. And then go ahead and divide it out. So you bring down the 1. 1 times 1 is 1. Add, you get 2. And this one's kind of interesting. Hey guys, what's the remainder? 0. It doesn't matter because we're not going to use it anyway, but you'll see why it's 0 in a second, right? So our horizontal asymptote, I'm sorry, slant asymptote would be y equals 1x plus 2. So 1x plus 2, or just x plus 2. So you're going to start up to, this is your y equals mx plus b. Start up to, and then do a slope of 1. And you should notice like something that's a little bit weird about that. Like what's kind of strange about that? Yeah, it goes right through the hole. Sorry, my dotted line got off a little bit there. There we go. So let's go back and get some points on the graph. Let's go back and do the intercepts. X-intercept will be something 0. You want to look at the factored version. What will make this 0? Good, -2. So you can plot that, and you should have another like question here, because where does that end up? On the asymptote, and you really aren't allowed to have a point on an asymptote. All right, but hold on. Y-intercept will be 0 something, so you're going to plug in 0. It doesn't matter if you use the factored version or the original version. So the factored one's a little shorter. If you plug in 0, what do you get? Good, 2. So when you plot that, it's also on the asymptote. Here's why. That asymptote is the graph. You can just go ahead and connect that all together. Because the remainder came out to be 0, it is perfectly the graph. So this one's just a line with a hole in it, which is interesting. And by the way, if you graph this on the calculator, the hole will not show up. I mean, your test is going to be non-calculator anyway, but I'm just letting you know, if you graph this, it will not show the hole. So like you have to be smarter than your calculator. All right, range, scanning downwards to upwards. Who gets left out of the range party? 3, good, why 3? It's a hole, gotta leave it out. Reading left to right, is the graph increasing or decreasing? Increasing, so decreasing is none, And so for increasing, you can copy over the domain. Ms. Cole, will we ever copy over the range? No, you will never copy over the range. It will only, you have to read left to right. That's why it's the domain. And then end behavior, limit as x goes to negative infinity of the function, limit as x goes to positive infinity of the function. And you can cover up the middle of the graph if you want, but this one's pretty easy to see. Where does the left arrow go? Negative infinity, right arrow, positive infinity.